Hello and welcome to our Wechsler Consulting Cloud News episode in October 2020. I'm your host Alexander Wechsler, and I'm really looking forward to present some of the highlights of the last months, which I have selected for you from all the Azure news coming out of Microsoft. Of course, October was not as flashy and shiny as September, but this was because of the Ignite conference, but we do have a few interesting topics I wanted to show you. We're going to start with our Azure Talk section for October 2020. And our focus topic today will be TinyML, Tiny Machine Learning, and this is very interesting, so please stay tuned if you're interested in IoT technology. Let's jump into our Azure Talk section, and we're going to start with Azure Active Directory. That's our identity provider in the cloud. And there's a new feature called Continuous Access Evaluation. And that does not sound really intuitive. Therefore, I wanted to show this to you with a little sketch. We do have our Azure Active Directory, which is the identity provider. And our user wants to log into Azure Active Directory to get an access token for the resource he or she wants to use. In our case, that's Office 365. It could also be any other application. So normally the user is requesting authentication, and if that's successful, he is getting back a token, an access token, which tells the application, if he's going to present this to the application, that he has the desired identity and he's able to log into Office 365. That's great, and there's also nothing wrong with it. The problem is that these access tokens do have a certain lifetime. Normally it's 30 to 60 minutes, and during this lifetime nobody would be able to reject them. And the new feature, Continuous Access Evaluation, allows the communication between the so-called relying party, which in this case would be our Office 365 application, and the identity provider Azure Active Directory. If something happens in Azure Active Directory, you now have a direct communication channel to the resource to tell the resource, for example, the user has changed his password. Please make the access token he's gotten and he's presented to you, make this access token invalid so that I'm able to generate a new access token related to the new password. And if you're looking, for example, to conditional access policies in Azure Active Directory, which allow users to log in only in a certain IP address range or area, so for example in Germany or West Europe, if a user then out of a sudden is in South Africa, which might be related to a hacker attack, then our application would also be able to notify this and tell Azure Active Directory, hey, this user is not logging in from a standard location. And by doing this, Continuous Access Evaluation closes a gap which has been a gray area since the beginning of using tokens for proving identity and authorization. The next feature I found very interesting is related to Azure Key Vault. As you might know, Key Vault is the place in Azure where you're going to store all your secrets, keys, certificates, and so on. The new thing is that it now provides an event grid integration. And this is absolutely great because anybody who has written an enterprise application and had to manage keys, secrets, as well as certificates has written a key or certificate management service looking into Key Vault if certificates or keys have been expiring or are close to expiration. With the new event grid integration, you get this directly from Key Vault itself, which means, for example, if a certificate is close to expiration, so 30 days before expiration, if you hook up the Key Vault to Azure Event Grid and subscribe to that topic, and the same is true for a variety of very interesting certificate and secret management events, which helps you to manage your secrets much easier, more reliable, and therefore much more secure. Azure App Service has been around for quite a while, but it's never too late for a new feature. One of the new features, which is called private endpoints, is really great. You may already be aware of private endpoints because several of the Azure platform services provide private endpoints, for example, SQL Server, Cosmos DB, and so on, which means if you have a secured virtual network with no external connection, so you're in your own IP range, for example, and you do have no internet access, then it's still possible to use platform services by defining a private endpoint in this virtual network. And this feature has now also been introduced to app service, which at the first glance maybe surprise you, because app services normally host websites or APIs and therefore quite often require internet connection to consume those websites or APIs from internet connected clients. But there are certain scenarios, for example, if you're working with virtual machines in a closed solution and you're not exposing any external endpoints, then private endpoints for app services make absolutely sense, because they give you the ability to route all the traffic inside the Azure data center without sending any data through the internet. And that's of course much more secure. And this is true for websites or web applications, for example, and of course also for APIs, which might be an even more interesting use case, especially if you're, for example, looking at internal applications which run on-premise and are connected into the cloud via an Azure gateway or VPN gateway. By using the app service private endpoints, you're now able to route your traffic from your closed data center on-premise into the cloud without exposing it through the internet. And that's a great security feature. After discussing some of the Azure October highlights in Azure Talk, let's now turn to our focus topic, which is tiny machine learning. Of course, machine learning is a very hot topic currently, and as always, if you look at machine learning, you have some standard challenges if you're working in a classical machine learning solution. Normally, you have to work with huge data load and data streams, and you have to handle those streams and work with them preferably via solutions like Azure Databricks and data lakes. And to cope with the data demands, you quite often also need powerful and therefore costly cloud hardware to process the data. And quite often, if you collect all the data in the cloud and you're also processing it in the cloud, it's not uncommon that these models may run into latency problems if they're tightly connected to real-world actions. For example, if you do person object detection in a video stream to open doors or something similar, if the data has to travel quite a distance through the internet, there might be latency problems. For example, that door cannot be opened in time because the person has not been detected fast enough. I have prepared something that should look like a standard IoT reference architecture in Azure. So on the left-hand side, we've got our embedded device or embedded devices, many of them, and those embedded devices do send their data into IoT Hub. IoT Hub, of course, receives the data, and normally here the data is split into two passes. One path is the hot path, where the data flows into stream processes, where the real-time processing is done. And this is also done with the help of machine learning models. So the stream processes quite often rely on machine learning models to create data, which then flows into business databases, and from there is taken as a base for business applications. So the applications normally are on this side. And by doing this, we have all the possibilities to use our data in the real-time context. And our machine learning models, of course, are used to create higher value events. For example, check against certain limits, detect certain limits, detect objects, detect persons, detect trends, which for example can be used for predictive maintenance, and of course also outlier detection. This is happening here. On the second path, which is the cold path, all our IoT data is stored normally in storage. It can be a data lake, it could be a normal blob store, depending on the amount of data you're dealing with. And from there, you do your batch analysis, for example, data mining and so on. But you also use machine learning workbenches to train your model, to do model inference, to create new models for certain use cases, or to update already existing models to refine them. And here we quite often require very capable processing power, because you have to handle vast amount of data in the shortest possible time to train and create the models. Okay, so this is classical machine learning. So we now come to the question, what is tiny machine learning doing differently? Well, the biggest difference is that the machine learning models, which are created, for example, in the machine learning workbench, are not used in the cloud anymore, but they are applied at the embedded device and run on the embedded device to pre-filter the data before it's sent to IoT Hub, which means that only higher value events reach the IoT hub, which decreases, of course, the traffic, the required processing power, and the amount of data you need to handle in your backend solution. That's one of the benefits. As we also can see, if you're leveraging unused processing power on embedded devices, we do not need as much processing power in the backend. If we are running on-premise, we do not experience any latency problems because we are as close to the ML model results consumers as we can be. To sum it up, the TinyML new approach is to run pre-built models, for example, which we have created in our machine learning workbench on small IoT hardware, but it does not stop there. We also are able to do continuous training and inferencing on embedded devices, which enables you to even react more granular to certain device scenarios where devices are in unique situations, and pre-built global models from the backend would not be optimized to fit into these scenarios. That's a very interesting use case TinyML can be leveraged in, and as already stated, we are fast because we're local. And this, to a certain extent at least, can be a game changer looking at IoT solution architectures of the future. Is it the future, you might ask yourself? Well, not really, because we already have implementations out in the market. With the help of IoT solutions, for example, such as Azure Sphere, it is possible to distribute cloud solution logic in a new way. We've been talking about that. The classical standard ML solution is send all your data into the cloud, and there it's got to be handled. The new approach, or possible approach, if your use case is demanded, is to distribute your solution logic wherever it fits best. And one thing you need to have if you're doing this is you need to have not only devices which are capable of running machine learning algorithms, which are small but still have enough processing power to run the models. You also need the means to manage them, to secure them, to update them, and to distribute software onto them. And that's a point where the Azure Sphere end-to-end solution can be a great asset to your project. Azure Sphere itself is a very capable multi-core platform. It consists of 4 processors. One of the ARM processors is dedicated to the Sphere operating system, which is a secure Linux distribution created by Microsoft, which handles all the security, device management, and software update related stuff. And the rest of the cores are able to run your applications. So especially if you need more processing power to, for example, create a machine learning model and you want to train and inference your model while you're processing the data, then you're able to leverage the 3 cores to fulfill these processing needs. And as mentioned, the end-to-end solution of Azure Sphere includes the security demand. So you're able to work on a very secure device, which is even able to serve as a secure gateway into the internet. Azure Sphere provides device operating system as well as application management, which you definitely need if you want to update your models. And having these important features already in place gives you a lot of freedom because you want to solve your use case, and therefore you're going to focus on the model implementation. And to have this in mind is a very important building block to a successful project. All right, one could ask, what are the standard use case scenarios for tiny machine learning? Anomaly detection, because these models are relatively easy to create. Predictive maintenance, it's also one I've already mentioned, but you can also apply it to more complex use cases, for example, object and person detection, and there's also a sample out, and the link to these samples you can find in the accompanying blog post, where you're able to do video stream analysis right on an embedded device, which is really cool. And last but not least, a very typical use case which helps to save bandwidth and costs and processing power in the back end is sensor fusion, which means that you're taking inputs from several sensors and you're creating higher value events from these sources. And this was a short view on TinyML, an area which is at the very beginning. I've provided additional links in my blog post, which lead you to tools and runtimes that help you to implement your first TinyML solution. And as already stated, I would start with Azure Sphere because of the completeness of the vision Microsoft is providing here. What else happened in October at Wechsler Consulting? We still have our interactive online courses out, and the great thing is, if you're looking into Azure IT Telemetry Jumpstarting OPC Unified Architecture, we're there to help. You're able to do the online course at your own pace, and with every course we are also offering 2 hours of consultation with the author or an available technical expert. And we also have created some new blog posts in October. One is regarding IoT projects and Azure Time Series Insight. Time Series Insight is a very helpful tool, especially in the IoT projects where you nearly always have time series based data. And we also did a post regarding Azure Stack Edge, which is Microsoft hardware you can rent, for example, to do a proof of concept or to implement a solution. The options in the Azure ecosystem grow day by day. That's it for this month's episode. I hope you find the information useful, and if there are any questions, please leave a message below. Thanks a lot and goodbye from Alexander Wechsler.